Assalamualaikum. We are going to talk about hexadecane. Hexadecane, commonly known as acetane, is a straight-chain alkane widely used in the petroleum industry, especially as a reference compound for diesel fuel quality. The IUPAC name of this compound is hexadecane, and it is known for its stable chemical nature and high composability. The molecular and structural formula hexadecane is C16H34. Its structure consists of a straight chain of 16 carbon atoms connected by single covalent bond, which is a typical characteristic of alkanes. Due to its nonpolar structure, hexadecane is insoluble in water and exists as a colorless liquid at room temperature. Properties of hexadecane have two. First, physical properties. Hexadecane is colorless liquid at room temperature. Hexadecane melting point is around 16 Celsius and boiling point around 287 Celsius. Hexadecane is insoluble in water and soluble in organic solvents because it is a nonpolar molecule. Second is chemical properties. Hexadecane is stable and unreactive because it is a saturated alkane. Hexadecane undergoes composition in the presence of oxygen to produce carbon dioxide and water, and can undergo substitution reactions such as halogenation. Hexadecane does not undergo addition reaction because it contains only single carbon-carbon bond.
Next is synthesis of hexadecane. First, add glacial acetic acid and zinc powder into a flask. Then add haloalkane, which is 1-bromo-tetradecane. Then slowly drip hydrochloric acid to release hydrogen. Then the substance is heated to approximately 100 to 110 degrees Celsius to form hexadecane or cetane. Next, I'm going to be talking about key steps in the synthesis of hexadecane. Step 1. Addition of glacial acetic acid into a flask, then add zinc powder to the acid. Then add haloalkane such as 1-bromo-tetradecane. Step 2. Slowly add hydrochloric acid drop by drop over 22 until 26 hours. Zinc reacts with HCl, which is hydrochloric acid, to release hydrogen. The mixture is heated to around 100 until 110 degrees Celsius while stirring. The hydrogen reduces the halogenated compound to form hexadecane. As we can see in the slide, we get the molecular formula for hexadecane, which is CH3, CH2, 14, CH3, which is C13H34.
Today I will explain the important chemical reaction of the molecule hexadecane, a saturated alkane widely used in the fuel industry. The first one is combustion. The main reaction of alkane is combustion. In the presence of excess oxygen, hexadecane undergoes complete combustion and produces carbon dioxide and water. The chemical equation for this reaction is carbon 16, hydrogen 34 plus 24.5 oxygen produce 16 carbon dioxide plus 17 H2O. This reaction is highly exothermic, meaning it releases a large amount of heat energy. Due to its efficient combustion, hexadecane is used as a reference compound in determining the certain number for diesel fuels. The energy release can be harnessed to perform mechanical works in engines. Second reaction for hexadecane is chain breaking or cracking. Cracking or chain breaking occurs at high temperature in the presence of catalysts such as zeolite. In this process, hexadecan molecules are broken down into smaller molecules such as alkenes. The example is butanes and pentane, or alkenes. The example is ethylene and propylene. This cracking process is very important in the petroleum industry because it produces high-value fuels that are more flammable and suitable for various commercial applications. The third reaction is low temperature oxidation. At moderate temperature, hexadecan can form alkyl peroxide radical ROO. These radicals are very important because they are involved in the initial ignition mechanism of diesel engine, which occurs before complete combustion takes place. The presence of this radical helps initiate the combustion reaction more efficiently and stably, making the ignition process more controlled in diesel engines. The last reaction is halogenation, radical substitution. Under certain conditions, such as exposure to UV light or heat, hydrogen atoms in the hexadecan's molecule can be replaced by halogens like chlorine or bromine. Example of reaction is carbon-16 plus chlorine 2 produce carbon-16, hydrogen-33, chlorine plus HCl, hydrochlorine. The product of this reaction is a haloalkane such as carbon-16, hydrogen-33 and chlorine. Haloalkanes are highly useful in organic synthesis because they can serve as starting materials in productions of various chemical products such as solvents, plastic, and pharmaceuticals.
Practical application used in industry, medicine, agriculture, and technology. Firstly, in industry, we use as a solvent in paints, lubricant, and coatings, a component in diesel and jet fuels, also used as a reference fuel in engine combustion studies, as a model hydrocarbon in combustion and chemical research. Secondly, medicine serves as a carrier oil in ointment and topical pharmaceutical formulation, used in thermal skin studies to test burn effect and heat transfer. Functions as a non-aqueous solvent in certain drug preparation. Thirdly, agriculture include pesticide and herbicide formulation as a carrier for active ingredients, used to coat seeds, delaying water or chemical absorption. Lastly, in technology, act as a reference standard in gas chromatography, used in heat transfer system due to thermal stability. Apply in fuel research and alternative energy technologies. Next, impact in particular application. Firstly, environmental impact. Low biodegradability, hexadecan is a long-chain hydrocarbon and can persist in the environment. Water pollution, if spilled, it can form a film over water surface, reducing oxygen exchange and harming aquatic life. Air pollution, when combusted, it can release greenhouse gas, CO2, and particulate matter, contributing to air pollution and climate change. Secondly, health impact. Low acute toxicity but prolonged skin contact may cause irritation or dermatitis. Inhalation of vapors at high concentration can cause dizziness, nausea, or respiratory discomfort. Ingestion is harmful and may lead to lung damage if aspirated.
In conclusion, hexadecan is a long-chain alkane that plays an important role as an energy source. It is widely recognized as the reference compound for measuring diesel ignition quality, known as the Ceten number, making it essential in the petroleum and automotive industry. So basically, the name of Ceten is from the Latin word which is iswale. Historians say hexadecane was the first isolated from whale oil before petroleum sources become widely used. Highlighting is early scientificated in fall research. Final remark, hexadecane may be a simple hydrocarbon, but its role in fuel performance make it a powerful contributor to modern energy system.